हरिः कर्ता।
Okay, we got to know about the scatter plot, but why you should use a scatter plot? That's the next question. Scatter plots are primary uses are to observe and show relationships between two numeric variables. The dots in scatter plot not only report the values of individual data points but also patterns when the data are taken as a whole. So identification of correlation correlational relationships are common with scatter plots. So in these cases we want to know if we were given a particular horizontal value, what a good prediction would be for the vertical value. You will often see that the variable on the horizontal axis denoted an independent variable. The variable which is on horizontal axis is always an independent variable, and you will the variable which is on the vertical axis, the dependent variable. So the relationship between the variables can be described in many ways, which is positive or negative, strong or weak, or linear or non-linear. Remember the words again: positive or negative, strong or weak, linear or non-linear. These are the way. So anyway, always the dependent variable y is on here y-axis, the independent variable which is on x-axis. Okay. So now the first type of scatter plot representation that you can see on the screen. So they're positively correlated, and they're tightly packed, and they're linear. So hence we call this a relation as strong, positive, linear. And the another type, so this is negatively correlated. So y is a dependent variable and x is independent variable. When x is increasing, the y is decreasing. You see that x is increasing and y is slowly coming down. As it goes on right side, y is coming down. So because of that, and that too, these data points are not closely packed, and that's the reason. Of course they look linear, so we call them weak, moderate, negative, linear. Okay, moderate, negative, linear. Then the next one, we have the third type of relationship, that is this data points were scattered around. There is no specific relation to there is no specific relation to focus, and here you can see they're randomly scattered around. So that's the reason we call them as a null, no relationship. And then that's what I just want to show you one more time. You see that they were scattered around, there is no particular relationship. And the third one, so far we have seen the linear ones, so now we'll be looking at the non-linear one also. So non-linear ones, based on the shape we will get to know that, and whether they are strong or moderate, you can just understand by looking at the data. So by looking at how closely they are packed, if you see this overall data points, they resemble the non-linear equation and they are all tightly packed. Hence we call this a relation as strong and non-linear correlation. And A scatter plot can also be useful for identifying other patterns in data. We can divide data points into groups based on how closely set of points cluster together. So scatter plots can also show if there is any unexpected gaps in the data and if there are any other outliers points. So this can be useful if you want to segment the data into different parts, like in the development of user personas. So the first example that you see on the screen here is the data clusters. There are two data clusters here. So the first data cluster consists of certain properties, which is y, the dependent variable, and an x and independent variable. So at this particular location, that's we'll take it as a one cluster. And the second cluster, which consists of high y value as well as high x value, that's a second cluster. So these two clusters will be separated with the different properties. And the second way of using our scatter plot is to find out, it can also show if there are any unexpected gaps in the data. So here is the example. So this is one data, and here there is clear cut unexpected, if you see this data where the scatter plots are plotted, and here, and this is closely packed, and this has a certain shape, and then after that there is a huge gap, and then again you have certain amount of values. So this can also be used to find out the gap in values. And the final one you can also use to catch the outliers. And if you see the whole data, so here you have the linear equation, linear relation, which are closely packed, and as the y is increasing, as x is increasing, y is also decreasing, you can tell that this is negatively correlated. But if you see on left side, there are two data points which are completely away from our relation, away from our trend or pattern. So these are called outliers. So we can use scatter plots even to find out the outliers. So now the most important aspect I just want to discuss before we move on to the another topic. So that's interpreting correlation as causation. This is not so much an issue with creating a scatter plot as it is an issue with its interpretation. Simply because we observe a relationship between two variables in a scatter plot. It does not mean that changes in one variable are responsible for changes in the other. So this gives rise to the common phrase in statistics that correlation does not imply causation. Correlation does not imply causation. I am repeating one more time. Correlation does not imply causation. It's possible that the observed relationship is driven by some third variable that affects both of the plotted variables, that the causal link is reversed, or that the pattern is simply coincidental. For example, it would be wrong to look at city statistics for the amount of green space they have and the number of crimes committed and conclude that one caused the other. This can ignore the fact that larger cities with more people will tend to have more of both, and that they are simply correlated through and other factors. If a causal link needs to be established, then further analysis to control or account for the potential variables effects needs to be performed in order to rule out the possible explanations.